Data scientists and developers use Teradata Vantage's massively parallel processing engine to analyze billions of rows of data at scale, seamlessly integrating geospatial data with customer insights all in one platform. No data transfers, no delays, just insights for faster decision making. In fact, one of our customers recently migrated one key geospatial processing workload into Teradata Vantage, and in this way eliminated data movement and reduced end-to-end processing time by 80 times, from hours to minutes. I am Janet Graziani, developer advocate at Teradata, and I am very excited to show you today how we work with geospatial data at Teradata. Geospatial data includes information such as latitude, longitude, and elevation of a location, and it has vast and impactful applications across various industries. For example, in urban planning, it drives smarter decisions on land use, infrastructure, and growth. In enterprises, it streamlines routes, tracks assets, and enhances network coverage for telecommunication providers. Now, let's explore a real-world use case on our free online learning site, ClearScape Analytics Experience. You can scan the QR code that appears on your site, create an account, and sign in. Once you sign in, you can easily create environments on Teradata Vantage. Once your environment is up and running, select Run Demos. This will take you to a hosted Jupyter lab on a separate tab, giving you access to over 200 Jupyter notebooks with use cases across different industries. We filter by geospatial analytic function and search for our telco network coverage demonstration. We will select the Python version. Now, before we dive in, let's take a minute to discuss how geospatial analysis can help telecommunication companies. Telco companies need to plan and optimize for tower construction to meet mobile connectivity demand. With Teradata Vantage and ClearScape Analytics, data scientists in telco companies can seamlessly integrate geographical data with customer insights and demand data, enabling them to identify high demand areas, optimize tower placements for maximum efficiency, and even integrate these geospatial insights with advanced AI/ML models to forecast future demand and strategically plan for network expansions. With this introduction, let's get started. We begin by importing popular third-party libraries like GeoPandas and Plotly, as well as our TeradataML library, which is Teradata's Python library that enables us to access advanced machine learning functions as well as in-database SQL functions. We then establish a connection to our Teradata Vantage system and retrieve data for this demonstration using a stored procedure. The dataset we're working with here includes geographical information for a variety of cell towers. Note here that we're using the GeoDataFrame module function, which is used whenever we're working with geometry data types. Geometry data types represent spatial data such as point for a single location, line string for routes or highways, polygons for enclosed areas like cities or counties. For non-spatial data, we use the TeradataML module function called DataFrame. In our dataset here, we see that we have rows that represent information about each distinct tower, including their location information defined by latitude and longitude, as well as their geometry data type. In this case, the geometry type is point, which represents a single location in coordinate space. If we invoke the TD types property, we can see the names of columns and their types. And effectively here, the cell geom column is classified as a geometry type. Now let's take the coordinates of each of our cell towers and plot them on a map to visualize their distribution. Teradata Vantage and ClearScape Analytics offer seamless integration with geo-visualization tools such as QGIS and Plotly. The process involves conducting all calculations and pre-processing inside Teradata Vantage, making only essential data available for our visualization tools. For example, in preparation for our visualization with Plotly here, we drop all unnecessary columns and we filter by longitude where our values are less than 152 to focus on a specified region. We then convert this to a pandas data frame. We then use Plotly Express to map our cell towers using the latitude and longitude. And in this way, we create an interactive map that gives us better insight into the distribution of our cell towers on this specified region. In this next example here, we demonstrate how geographical data points about customer experience can be analyzed and visualized on a map. Here we have another geodata frame with geographical data points about customer locations and their corresponding RSCP values, received signal code power values, which indicate the signal strength quality of their various devices at different locations. To plot this information, we create a new geodata frame by dropping certain columns and creating columns for latitude and longitude, as well as categorizing RSCP values. For any RSCP value that is less than or equal to negative 100, we label that value as poor. For any values between or equal to negative 100 and negative 86 are classified as good, and any value greater or equal to negative 85 will be classified as excellent. With our data labeled, we can now proceed to plot our data. For this, we first convert our geodata frame to a pandas data frame, and we use Plotly Express to visualize our signal strength. This enables engineers to quickly visualize the different signal strength across the region. Up to this point, we have learned how to work with geospatial data using TeradataML's geodata frame. We also analyzed and visualized points that represent cell tower locations on a map, and we assessed and visualized signal quality across a specific region. Next, we will learn how to work with GeoJSON files on Teradata Vantage. We have been provided with a GeoJSON file that covers network area under consideration. If we navigate to our file, we can preview the contents. GeoJSON is an open standard geospatial data format based on JSON that is used to represent simple geographical features like point for a single location, line string for linear features, polygons for enclosed boundaries. In this specific example here, we have an array of features that is used to represent areas under consideration. It uses the multi-polygon geometry to represent counties and their respective coordinates. If we navigate back to our Jupyter notebook, we load the JSON file and parse the data. We then flatten our features into a data frame. We extract unique site IDs and iterate through each unique site ID to append a color code, a number for a color code. And this allows us to map our area using Plotly Express. In this way, we can visualize the area under network consideration, enabling engineers to quickly identify the location of existing towers, as well as evaluate the signal strength in various zones. In this final portion of our demonstration, we highlight Teradata's Unbound analytic framework that helps us simplify and automate time series and geospatial data analysis. Specifically here, we will use the TrackingOp function to help us calculate customer trip distance, speed, time, as well as visualize their trajectory. Here we are working with a data set that includes over 250 customer journeys with information such as their incremental journey sequence, timestamp at every step of the journey, as well as signal strength and coordinates for every step of the journey, includes mobile app usage and more. This dataset is a goldmine of information for telco companies that enables them to extract information about customer movements as well as their network coverage. To sample deriving these insights, we take a sample subset of customers to work with. We then create two columns to transform our data and prepare it for further processing. Here we're creating a column for our departure timestamp. And here we are converting geometries for further processing. The resulting table contains critical columns such as arrival timestamp, departure timestamp, and our geometries. And then we can proceed to use the TD series function to create a TD series object that will be fed into our TrackingOp function, and the resulting output will be our customers' information about our customers' trajectory, including their total trip distance, their minimum speed, average speed, maximum speed, and total trip time. We can then plot this information as well using Plotly Express to have an easier time visualizing each customer's journeys. And here we can see that the color-coded markers show signal strengths: green for excellent, red for poor, and yellow for good signal. Beyond this telco example, UAF's TrackingOp function empowers enterprises across different industries. For example, logistic companies can use this function to track asset movement, also to identify the most efficient routes, and even to optimize delivery schedules and save on fuel consumption. Thank you all so much for watching. I hope you have enjoyed this quick recap of how we work with geospatial and time series analysis. Until next time.